Hey guys, so today we're going to go over polynomial operations. Keep in mind that we have kind of the same rules going on here from operations with complex numbers, which is you can only add and subtract like terms. And when multiplying like bases, remember to add the exponents. So you always want to look at what's happening between the parentheses, even if the instructions aren't there. So notice that number one, it says to add. So we're going to look for the like terms to add together. I have x to the third power, and it's being added to 4x to the third power. Remember, if there's no coefficient in front of the variable, it's a 1. So 1x to the third power plus 4x to the third power. I add the coefficients, which give me 5, and I keep the like term x to the third power. For x squared, again, that's a positive 1x squared, I'm going to take negative 5x squared. So 1 minus 5. So keep in mind that's a positive 1x squared minus 5x squared. Signs don't match for the coefficients. I subtract, take the sign of the bigger number. The bigger number is 5 and it's negative. Bring down the x squared. So that would give me negative 4x squared. Now if you look, I have a constant, negative 5. And in the second parentheses, it doesn't have a like term. I have just negative x. So because they're not like terms, I'm not going to add them. Rather, I just bring them down. Remember, polynomials need to be written in standard form, so meaning greatest exponent to smallest exponent. So x to the third, x to the second. I'll bring down negative x to the first power, and then the constant, which is the number that's by itself, which would be negative 5. And that's it. So this is simplified, and then we're going to move on. When you have two polynomials that are being subtracted, I recommend that you distribute that negative to the second parentheses first. Otherwise, you have to remember there's a minus sign, and if there's a negative here, minus negative would give me plus. So I would suggest distributing the negative ahead of time when you're subtracting. So meaning you're multiplying everything in the second parentheses times negative 1, basically changing its sign. So negative 1 times 7x to the 6th power is negative 7x to the 6th power. Negative 1 times negative 5x squared would give me positive 5x squared. And negative 1 times negative x is positive x. Everything in the first parentheses, well, there's nothing in front of it, nothing to distribute, so I'm going to bring it down exactly how I see it. And since there was nothing to distribute, no need for the parentheses. Sorry, I'm trying to like just squeeze everything in there. Okay, so we're going to combine like terms. First of all, 7x to the 6th power. X to the 6th power is here. And it's also 7, and it's a negative. So 7 minus 7 is 0. We're not going to write 0x to the 6th power because anything times 0 is just a 0. So we're just going to get rid of it. Now I have 5x to the second power, and here I have 5x to the second power. So 5 plus 5 gives me 10. Keep the like term, x to the second power. And from here I have negative 5x plus, that's a 1x, so negative 5 plus 1 gives me negative 4x. And that's pretty much it. There's nothing else to combine. Moving on, remember when we multiply like bases, we add the exponents. So I'm saying this for the next problem when we're multiplying. So notice for number 3, we're just distributing. There's a number in front of x, or a term in front of the parentheses, sorry, a term in front of the parentheses. So we're just going to distribute. I put a 1 here. So if I'm multiplying, 3x to the first power times x to the third power gives me 3x to the fourth power. When I multiply, I add the exponents. Here I'm taking 3x to the first power times x to the second power. So the 3 again comes down. It's a positive 3 because I'm multiplying 3 times positive 1. X to the first power, x to the second power. X to the first power times x to the second power. Again, when I multiply, I add the exponents. 1 plus 2 gives me 3. And then finally here, 3x times negative 5. 3x times negative 5, well, 3 times negative 5 is negative 15. Nothing to do with the x, so I just bring that x down. And then for number 4, This should look familiar. We did this with complex numbers. We have two binomials being multiplied to each other. So binomials means there's two terms in each parentheses. Terms are separated by plus and minus signs. So in order to multiply two binomials together, we use the FOIL method. You can also distribute, but I'm going to use FOIL. And FOIL again means first, outer, inner, and last. So first, I'm going to multiply the first term in each parentheses, 5x times x. So remember, this is both x to the first power, and when I multiply like bases, I add their exponents, giving me 5x to the second power. And then outer, the two on the outside, 5x times 7. So if I take 5x times 7, that would give me positive 35x. Inner are the two on the inside, so I have negative 2 times x. So negative 2 times x is just negative 2x. And then last. So last, I have negative 2 times 7. So if I take negative 2, and I'm going to write that here, negative 2 times 7, I'm going to get negative 14. Bring that down. And then from here, I just have adding and subtracting. So after you multiply using FOIL, you just have an adding and subtracting problem where you're combining like terms. Remember, you can only add and subtract like terms. So that 5x to the second power, there's really nothing here that has x to the second power. So I'm just going to bring that down. However, if I look at the outer and inner, the two on the inside, these both have x to the first power, so I can combine them. 35 minus 2 would give me positive 33, keep the like term, which is x, and then there's nothing else that is just a constant, so I just bring down the minus 14, and that's it. So you know you're done because you're adding and subtracting, and you don't have any like terms left. All right, guys, hope this helps.